All right, guys, I want to make sure everybody's on the right track with these. I'm going to look at the first one here. So we've got the mean. How do I know I can draw this picture and do this problem? Yeah, it's approximately normal, so that means it's normal enough to do this problem. So I put down there 930 and 1200 roughly. So I want to know this area. One big mistake I see is somebody makes one z-score doing 1200 minus 930. It makes no sense. The z-score is in relation to the mean. So you have to make both of those into z-scores. Look them up, get the area, subtract them. So if I make 930 into a z-score, what do you guys get for that?
Negative 0.27.
Negative 0.27 sounds right. So this is negative 0.27. This is always 0 in the middle. And then
1.7.
yeah, thank you. 1.7. Oh, okay. All right, let me stop for a minute. I want to point this out. You can make a z-score any damn time you have x mean and standard deviation. But what's the only time that I know exactly what probability it relates to is if it's normally distributed. So I made z-scores here, and then I'm allowed to use this chart to get the answers because it is normal. When you look up 1.70, what do you guys get? Who do what?
0.5871.
No.
Oh, wait, so which one?
9554. Cool. You need a... Come here. I like the matching outfit. All right. So if I look up 1.7, this is going to be way too much area to be the answer, right? I know I've said this before, but I really want to get it through everybody that what you do here makes complete sense. If I look this one up, I subtract it, and that leaves the area in the middle. It's almost too much to believe that it's that simple of an idea. So if you look up negative 0.27, negative 0.27, you guys got this here? 3936. I like it. If you're still having trouble reading that z-score chart, you probably want to call me over in a minute. Oh, what's up? Because the next number was, I think, a 9, right? You have to truly round, or else in a way you're kind of lying. Yeah. So I think I said this last time that if you did this in the calculator, it wouldn't round anything. It would give you the exact right answer. I don't care, because then you don't learn anything. So I'm fine with these being rounded and not quite exact, because then we're actually learning more, is the hope. All right, I already forgot what I said here. It was 0.3936. So to get the actual answer, I have to do 9554 minus 3936. 5618. So about 56%, just a little over that, of the places in this part of New Zealand would rent for $930 to $1,200 a month. Now, before you go a little crazy with jealousy or something, they also get paid less, right? So everything kind of stays relative. But then you just make a lot of money here and then move there. I'm not really sure what that district is like, but New Zealand is, I hear it's awesome. And I saw Lord of the Rings, so
They'll only take you if you're like an engineer, mathematical, but like artists and other like.
I'm saying like retire there, you know.
No, they're really thinking about it.
Oh, I know. Yeah. They want people with skills.
Yeah.
I don't blame them. All right, here we go. This guy is the one I talked about a minute ago. You've got to let the picture help you. 95th percentile. You can't forget what that means. That means that's going to be the score that has what where. What does 95th percentile mean? It's the rent that has... What does 95th percentile mean? 95% of the other rents are below it. Yeah, that's it. That's what a percentile always means. If you got the 70th percentile grade, 70% of the people scored less than you. Right? Okay. So how do I know where this z-score is going to be? Because it's got to have 95% below it. So it's got to be somewhere way the hell up there to have 95% of it below it. Therefore, I know it's going to be a positive z-score. It's above the mean. And you normally know a z-score and then look up the area. Here I know the area, and then I can look out to see what the z-score is. Something a little weird does happen for this one specifically. If you look up 0.95, the closest you can get is actually two different ones. They're both 5 away. This is 164 and this is 165. So what they do is split the difference. 1645, right in the middle. Let me try again. So if I think it's this, that's 1.64. Is that cool? But that is the same distance away, and that's 1.65. So there's a situation where they go, all right, we'll just split the difference, average those, bless you. And I get 1645 for the z-score. So, a few different ways you can look at this. How far up do I have to go until, because right here, what percentage is below this? 50%. The mean cuts it in half, right? So how far up do I have to go until I've got 95% behind me? Well, now we know it's got to be 1.645 standard deviations. Now, don't tell me that the rent is $1.65. If it was something really wrong with the neighborhood, you probably do not want to live there because you won't survive long enough to enjoy the great rent, right? So how do I convert that into an actual rent? Well, I can use this formula because math goes both ways. Right? You can be jealous or whatever. But if I know x, I can make it z. If I know z, I can make it x. So here I know what z is. So let's be a little smarter. Some of you guys might have put it in this formula and then solve for x. Let me solve for x right now and make a general all-purpose formula. How do I solve this for x?
Multiply by standard deviation.
Multiply by sigma. So I get z sigma equals x minus the mean, and then I add the mean. So I get x equals the mean plus z sigma. I can't remember if I've done that with you guys already or not, but does everybody see that? Is that all right? That's where algebra comes in and says, hey, I got a use. Now look at this. Stay with me. I said earlier, I reminded you guys about that question I'm going to ask you in every test. What does the z-score tell you? So let me see if you guys, can somebody tell it to me again? The number of these from the mean to the data point. So if you read this mathish statement in English, it exactly states the answer to that damn question. It's crazy. Right? 1.645 steps above the mean. Wouldn't you do 1.645 of these and then add it to the mean? Isn't that what you would just do? So of course the formula better freaking say the same thing. And it does. Thank God. So you're not allowed to have notes on your formula sheet, but when the formula is a note, what can I do? Oh well. Baby. So what do I know here? I know the mean, 966.84, and I want to go up this many steps. What was that? Where'd it go? 136.91. That is actually something you had to do back in 2-7 homework. And it's actually something we did on the first test. We just didn't call it, we didn't give it this formula yet. And then whatever the hell that is.
1192.06.
Where are we at? 1192?
0.06.
Is that what you guys got?
Yes.
Sounds familiar. I remember making a joke about don't forget the sixth sense. And then it's not sixth sense, sixth sense. All right. I see that. Let me stop there for a minute. You guys. All right. I'm going to need some more room, so I'm going to do that. All right. So to do this one, 966 still in the middle. 1600's way the hell up there. I want to probably more than that. So I know going in a couple things. The z-score should be positive. The answer should be very, very small, right? So I love it when people try to tell me the answer that's like 80-something%. 80%'s in that little tiny? No, that's no. So if I make this into a z-score, my point that I'm curious about, minus the mean, divided by the spread, you should get something that might freak you out at first. 4.62. Now, hopefully everybody's at the point where in this semester, if I said somebody's height had a z-score of 4.62, you should go, holy shit, that person's tall as hell. 4.62 standard deviations above the mean is insane, right? So what's the probability? You should already kind of know, without even looking at the chart, what's the probability something would be above that? Should be basically zero, right? And sure enough, when you look at it on the chart, I'm about to disagree with the chart a little bit, but I'll accept what it says. If you look at the chart, it kind of gives up here. You can sort of see why. Do you guys see how, is it changing a lot up here? No. Like down here, was it changing much? Shit, yeah. So why is it changing so little? Because then you're way the hell out here where there's not much. So every time I take another step out, I'm not really getting more area. But, I mean, once I'm at 4.62, I'm not going to be 0.999 anymore. I'm going to be 0.9999992 or something. But you can do this. You can go ahead and take the number they put. And where, of course, does it go? Always below what you just looked up. And then the answer you get is going to be 0.0001, right? Now, I would say the answer is about 0%. So if it's off the chart, you can just use what the chart says, or you can actually just say that's about 0%.
So if we get a problem like that when we're like just looking at the problem, we can see it's going to be probably like around 0%. We just put about 0%.
You better make sure the z-score is above 3.5, right? Maybe the z-score is 3.48. See what I'm saying? And then you got to give me the exact. Yeah, okay. So be careful. All right. So if you haven't finished 2 up yet, go ahead and do that. If you have finished 2 up, good job. Just hang out for a bit.